ready.
Okay, let's just get started. So this afternoon we'll have 4 talks in a row, and we'll end the day at 4 o'clock. First speaker is Yee Sian Ng, fellow ORC graduate student, and he's going to be talking about the internals of JuMP's macros.
Okay, so hi everyone, I'm Yee Sian, currently interning at Los Alamos as well for this summer. So, I don't know, how should I start? I think I'll start by describing my first interaction with maybe the JuliaOpt developers, which was about 4 years ago, just to give you a sense of how things have changed since then. So I think the first time I encountered Julia and JuMP was around 4 years ago when the Julia developers made that announcement about why we created Julia and how Miles and Ian came in and also started talking about how they started to build up this DSL as a modeling language for mathematical programming. And so we mostly met on this forum called OR Exchange. I don't think we've updated the post for quite a while by now, but basically the idea is just them sending a blast out to the world saying that this exists right now, this is awesome, you should check it out. And then me coming in and saying, oh yeah, this is really great. I used to do stuff in Python, and I wanted something for me to be able to build up on top of in order to build up abstractions for modeling uncertainty and optimization problems. And then I was then asking them where do you see stuff heading, so on and so forth, and they were saying, oh yeah, lazy constraints are coming in, all sorts of good stuff that you come to expect and love in the C and C++ interface. And all of this was in October 2013, so 4 years since then, quite a lot has changed as well. And so for today, I think I'll be talking a little bit about that, if you are a developer today, how you might want to interact with JuMP, what kinds of stuff you might want to look out for based on what I've currently observed in the code base. Okay, so just hopping back to the notebook now. So as an overview for this talk, I think I mostly want to cover 3 stuff. The first one is a motivation for why you might want to start thinking about writing macros, and then go through a quick example using some code snippets from JuMP chunks and a few other extensions to JuMP. And then finally, maybe if we have time, have some discussion about what exactly we're talking about when we talk about working with JuMP. Okay, so the first one would be why macros. So I think for me it's mostly 2 reasons. The first one is when you might want a cleaner syntax for modeling your models. So I think one usual design pattern when it comes to writing research code and working with data is you start off building up some object that represents whatever problem you're trying to model, and so that object would usually capture most of the information inside the problem that you would then use to build a JuMP model on top of. And this is a pattern that's present there in powermodels.jl and probably a few other packages as well. Okay, so suppose for now you actually have such an object which we call PM, standing for Power Model. Okay, and so I think the way Power Models has been set up is you might pull out variables from inside such an object, and then you might have keys corresponding to variables in some model, for instance. So this is currently just taken from the code base in Power Models. If you click through, you kind of see how this is basically a pattern that's used in a lot of the functions, where basically you're always pulling out variables before constructing constraints from them. But you might want something simpler, right? You might want to just directly model that inside JuMP's constraint rather than having to pull them out from some external object before putting it into JuMP. So cleaner syntax is one reason why you might want to start looking at a macro, so that you can start rewriting some of this code that you otherwise be writing over and over again. Okay, so a second reason, which I just cooked up this morning, is basically there's some correlation between developers who understand JuMP's macros. So if you kind of look at JuMP's contribution history and you look at the top few developers, Miles, Joey, Ian, Benoit, and Oscar, you'll notice that a lot of them usually go on to write macros in the extensions that they build on top of JuMP as well. So there is some indication or some signal there that maybe macros might not be a bad way of, might be something useful to you in practice as well, like when it comes to like being able to build up like cleaner abstractions and cleaner syntax so that you can start focusing more on like the problems that you have at hand. Okay, so this notebook was written quite at the last minute, and so like I'll post it like after the talk, but like basically I'll have all of these links in there so that you can like, sort of check out what kinds of extensions are currently available, what are some of the ideas that they've used inside the extensions. I think because this is all kind of new and relatively like unexplored ground, so like we're all kind of like trying to gather data points on how people might want to structure their research code and like what kinds of patterns are useful that we might want to eventually surface to JuMP. Okay, so I think what I'll do now is I'll step through a quick example based on an extension called JuMP's that Miles has written. So I think it's illustrative of a use case, I guess, of a problem domain where you might want to model uncertainty in your optimization problems, and kind of usually it ends up being reformulated into something else, but like you want the user of the package to think in terms of the underlying uncertainty, in terms of the underlying problem structure, and to worry a lot less about what it gets reformulated into. Okay, so I think JuMP's is quite a good and illustrative example of such a package. So I'll just run this code for now. So basically, the way it works is you import the package, and Julia has this package called distributions.jl. Okay, so the way it works is you would create a model, kind of similar to how you otherwise create it in JuMP. You might define variables corresponding to the uncertainty inside your coefficient matrix. Okay, and then you do the usual thing, define a variable in JuMP, maybe call it Z. Define an objective where you're trying to minimize Z, and then like maybe have some constraints on Z. Except that this time around, the constraint matrix contains random variables. In this case, a normally distributed random variable with mean 0 and variance 1. And you want this constraint to be to hold true with a probability of maybe 0.95, for instance. Okay, so JuMP's basically does the work of reformulating it, or like maybe generating cuts, so on and so forth, such that you can just call JuMP solve. Okay, and when you call it on this chance model object, you would basically be able to pull out the values and see that it basically satisfies the contract that JuMP is supposed to satisfy. So kind of what I hope to achieve by the end of this talk is, if you have something similar in your research where you might come up with a robust formulation or something else, and you kind of want to develop a package that you use later on, rather than just sort of writing out all the code from scratch from first principles as you step through your paper, maybe this is a way you might want to proceed in thinking about how you want to structure your package. Okay, so when working with JuMP's macro utilities, let me see. So I think what I'll do here is I'll first show you, if you are writing a macro, like what are the things you need to look out for, sort of giving you a quick like orientation to the way macros are written, and then sort of give you a quick peek under the hood of what is happening inside JuMP whenever you call add variable or add constraint. Okay, so if we look at JuMP's independent normal macro, which is the macro that is used for sort of generating normal random variables. So the way I might go about doing that is usually I'll write a macro that just takes the arguments or the parameters that is otherwise defined in the original package, and I'll just return them just to see what the objects are like. Okay, so over here, what we do is we define a macro that I'm just going to name it similar to what it was in JuMP's, and it takes in the model, the variable name, I guess, the mean and the variance. Okay, and then it just returns the same stuff, just so that I can see what kind of object it gives us. So if we write that macro and we invoke it, okay, you can see how basically when we pass in an m, an x, a mean and a variance, it basically interprets them as symbols or expressions. Okay, so over here, m is no longer a concrete JuMP object or no longer a concrete chance model object. It is instead a symbol that you can then work with in order to write the actual code that you want to write under the hood. Okay, so what we want to do is we want to use this information encoded inside these objects over here, and we want to rewrite it into the code that we actually want to run. Okay, so we might want it to look something like that. Okay, so we might want to define a variable x over here. We want to set it to be some independent normal object, okay, where it is attached to this model m over here, along with the following keywords and arguments over here. Okay, so this is one way you might want to think about, like maybe you might have some specialized object inside your package, and maybe it involves a lot of custom code that you kind of don't want your users to worry about. And so a macro might be a good way of proceeding, where like basically you're kind of doing a lot of this rewriting under the hood. You might ask, why a macro instead of just defining a function? And the main reason is because with a macro, sometimes maybe you get certain syntax benefits that I described earlier on that you otherwise don't get with writing a normal function. Okay, so ideally, this is maybe code that I'd like to be able to write inside a macro, but as you go down this road of writing macros, you need to observe certain things, and kind of we call them macro hygienes, which is basically macros are invoked at the first time when the function is being compiled, and so maybe it doesn't have access to kind of the objects that you want to be able to access at the point when the function is being compiled. Okay, so over here we might have m, x, a mean, and a variance, where they're all symbols, but in practice we kind of want to what we call escape them, so that we can get the actual reference of what that m is supposed to capture, along with the actual means and variances and so on and so forth. Okay, so there is a link to the manual where basically they describe how you might, which basically does a tutorial or introduction to how you do meta programming inside Julia. I won't go through that, but I'll just show you a rough sense on how you should be rewriting code like this into something that actually works in practice. Okay, so the main idea is we want to do what you call escaping, which is kind of like, I don't know, what is it called? That movie, where like basically you're escaping from a dream. So you might imagine now you're inside a dream right now, and kind of like you want to escape from the dream and you want to be able to jump out of it. So the escape would do that, basically. So you have this m as a symbol, and you might want to escape that dream and get the original like chance model that's being invoked inside that function. And you do the same thing for the mean and the variance. And so when you do that, kind of what you get is something that looks more ugly, but is actually correct Julia code. That is really what you want to be plugging into the function that you're usually writing your macros inside. Okay, so this is kind of like, let me see. So you can kind of think of this roughly as something like interpolation of the stuff that you want inside. But yeah, I won't go into it. So the basic idea is basically inside macros, usually you're working with symbols and expressions, and you kind of want to be able to escape them in order to be able to reference the actual thing that you want in practice. Okay, so you'll see quite a lot of this whenever you start looking at code involving macros. Okay, so and things get ugly quite fast whenever you start working with macros, mostly because you don't have type information. There's quite a lot of things that you kind of take for granted in Julia whenever you're writing functions that no longer becomes available when you're working at the level of macros, just because a lot less information is available to you. Okay, so JuMP has some utilities for whenever you're writing macros for like passing the expressions and converting them into objects that you might find more convenient to work with. So one of them is called build_ref_sets, okay, which is written by Joey, and he was like, yeah, Yee Sian, you're like taking all of these like methods that I wrote that's meant for internal use, and like kind of like making everyone more aware of it, and like eventually like we had to like commit ourselves to like some interface on how we want to work with expressions and symbols, which is kind of like not something that they would prefer to do like at the start when everything is still kind of new and unexplored. But I feel like as JuMP is maturing and stuff, like we would more and more users of JuMP might come to rely on inside the research code. So we might as well start having conversations about exactly how this stuff is written now. Okay, so sorry for the digression, but basically we have utilities for whenever you're writing macros to be able to like take expressions and symbols and convert them into convenient information that you would otherwise want to work with inside your macro. So if we go back to our previous macro, this independent normal thing over here, and we sort of output this n, x, mean, and variance, and we show what they are, you'd see that they're basically in this form over here. Okay, so now you might have keyword arguments, you might have a somewhat more complicated expression for the variable you're trying to construct along with the model object over here. So if you look at what our previous macro was doing, it was just basically plugging in the variable name into the left-hand side of the expression and then sort of formulating some expression for the right-hand side. But it doesn't really work here, right? Because if you look at the variable over here, kind of like what you would have to do inside the macro is to basically write a loop that loops over the indices inside the parentheses over here, separated by the commas. Okay, so the previous macro doesn't actually work over here, and so what build ref sets does is basically it takes in all this information and it builds up sort of the information on the indices as well as the range of the values that they might take, so that you can write a loop inside the macro. Okay, so this is just a command that was taken from inside the code base. It's basically unexported, so if you use it, like, sort of be prepared for the possibility that it might change or break, like in subsequent versions. But basically what it does is it takes as input an object representing a name, associated index, so on and so forth, and then it sort of returns all of these values over here, which you would find useful whenever you're writing such macros inside your own package. Okay, so if we do that, so we have x over here, which is basically this somewhat more complicated expression over here. If you dump it out, you basically see that it captures all of the information that you want to be able to write the loop inside the macro. Okay, so you have the variable name, and then you might have I equals to I belonging to the set from 1 to 4, j belonging in the set from 1 to 3, so on and so forth. So you can kind of dive into this abstract syntax tree and plot the information that you need for generating the code that you want to otherwise write. Okay, so but kind of like after a while you realize that that's kind of like a design pattern that's used repeatedly. So you might as well use this convenience utility that's already present in JUMP that sort of pulls out the reference call. In this case, I mean, it's this one over here, which is kind of like W with I and J interpolated into it, and then sort of having the variables that are being used as the indices, which is I and J over here, so on and so forth. Okay, so this is basically useful information that's going to come on later on as you're sort of writing the code for what you want to be able to do, which is to write a loop that like sets, that builds up like this composite variable object over here. Okay, so in order to construct the string that corresponds to the variable name wij, it's kind of complicated within a macro, which is basically you need to sort of get the name of x and then sort of build up a string iteratively. So getting the name of x would just give you the omega over here. You need to sort of loop through what the index variables are, which is I and j, and then sort of like append them separated by commas inside the parentheses. Okay, so at the end of it all, like you basically end up with a string that corresponds to the variable. Okay, which basically is kind of like that, but like within the setting of a macro. Okay, so this is generally kind of like, yeah, it looks complex and stuff, but like after a while of writing macros, you kind of get used to it, and then sort of like we really want like better ways of thinking about how we can write code without like killing ourselves whenever we are writing or reading macros written by other people. Okay, so that's build ref sets. The main idea is you start off wanting to write your own macros, and then whenever you start encountering somewhat realistic examples of syntax that arises in practice, you want convenience functions for converting them into useful objects that you can then use inside your own macros. Okay, and the first one is build ref sets, which basically builds up indices corresponding to all of these sort of composite variables that we have over here. So the second one is to actually write the loop that generates those variables, and this is used a lot. So there's also another convenience function called getLoop code. Okay, again, this is unexported, but basically the way it works, I'll just show you, is you might generate a symbol corresponding to some anonymous variable, okay, and then write some code that generates it. And then finally, JuMP.getLoop code would basically write the code that writes out the loops with the inner expression that you want to repeatedly invoke inside that loop. Okay, so what it looks like, quite ugly, but if you stare at it for long enough, you'll see some familiar stuff, which is basically the usual for loops that you might otherwise write. So this is for I in the range 1 to 4, and then a few stuff I don't understand, but like inside that outer for loop, you'll have inner for loop, which loops from J from, I guess, 1 to 3 in this case, and then you sort of build up the variables from there. Okay, so you have Wij being equals to independent normal of the stuff that you otherwise do. Okay, so that is basically it. Like kind of like if you want to get started writing your own macro, you might want to think about JuMP.build ref sets and as well as JuMP.getLoop code. Sort of look through some of these examples. After a while, you get the hang of it, and maybe you might realize after like maybe 1 week of banging your head against the wall that it's not such a terrible way of proceeding. If you want to have a nice sort of user experience for like people who are using your package, including yourself. Okay, so any questions up to this point about like what's the point of like why are we like subjecting ourselves to like all this like monstrous like way of writing code and sort of what we hope to gain out of it? Yes, Colin.
So I guess I don't super clearly understand when you would want to use a macro instead of a function, with the exception of maybe changing syntax.
Correct.
I mean, is there?
That's pretty much it.
Okay. And then I guess, so I read this thing in the Julia style guide that was, it says, don't overuse macros. Do people know why that's part of the style guide?
So you kind of prefer not to use macros if you can avoid it, for kind of just off the top of my head for 2 reasons. The first one is it's a lot harder to write than a normal function. And the second one is kind of like all of this information is being kept inside the macro rather than being surfaced to the Julia compiler, which otherwise might have more information to work with whenever you're just writing a normal Julia function. That's my own understanding.
And also, users don't know what's going on.
Yeah, and error messages are much worse. Or they were much worse. They're better now, but they're still not as good as what you might have at runtime. There are a lot of like they're kind of magical, so I feel like people started being like, oh, we can do a lot of cool stuff with macros, and so like years ago, people would like write all these macros to do things they didn't really need to do, and then it was just kind of like bin dubs, like I think there was like a overcorrection because it's really cool, and that the reason that it's in the style guide is because they kind of wanted to push back on it.
Yeah, I guess, I mean, part of learning a language is like knowing all the syntax, right? And you get really productive when you basically memorized 90% of the syntax. So I'm very hesitant to define any new syntax because I want people to be able to just like read it, and because they know Julia, they understand it.
All right, so one more question from the side.
It seems like when you have some like strange input for function, you would love to do the macro thing, because you can, like I see that you're trying to parse the input and to try to understand them in like a basic way. Mm-hmm. Is that one of the reasons that you might want to do it? Yeah.
So maybe you might not want to be writing your own macros, but maybe you might want to understand what is happening whenever you call JuMP.addMacro and JuMP.addVariable and JuMP.addConstraint, for instance, so that you can see how your own objects get hooked into JuMP and math base later on, so that you can kind of see like what interfaces you need to satisfy in order for your own custom objects to also work with JuMP's macros, for instance. So maybe the previous section is somewhat less motivating for like writing your own macros and like kind of more useful when it comes to like understanding what exactly is going on inside other people's macros, for instance.
Could you cover, if I have a macro, can I get the equivalent Julia code easily?
Yeah.
Yes. So I think Juan Pablo earlier was talking a little bit about how you might want to like have a kind of record of the history of commands that were used to modify a JuMP object, so that like maybe someone later on can sort of dump or print out like the history of commands that was used to define the model. So what the macros, like you could possibly like add in commands that sort of adds on like those syntax into like kind of like an attribute of the object, basically capturing the history of all of the commands that was invoked on it. Like, so that might be one way of going about it.
I mean, I guess it's a bit more for the discussion at some point,
Right.
but it's essentially the macro for JuMP. Using the syntax that is in the macro is the natural syntax for optimization, which is great. Now the problem is, what if I now want to be a more advanced JuMP user and I want to contribute and I want to try to understand what's going on with JuMP? Macros obscure a lot of what's going on because they're hard to understand.
Right.
But maybe dumping the output of the macro or having examples, okay, this is what the code you write on this macro, this is the code that would output, that will be enough for you to kind of like, oh, okay, now I won't be able to write my macros, but then maybe I now, the internals of JuMP are not that obscure. But I think it's like that transition is the one that, from the I'm a consumer of JuMP to a contributor to JuMP, I mean, I've actually had trouble understanding what's going on in the JuMP code.
Right, right. I mean, I myself as well, even after 3 years of like working with it and using it and stuff. So I don't have a lot of time left. I'll just like do a very quick sort of step through of what happens under the hood whenever you call JuMP.addVariable and JuMP.addConstraint, just so that you get some rough sense on like what are the methods that might call, and so if you might have your own custom variable or custom constraint, like how you might want to structure it so that it works well with everything inside JuMP, or at least how we're thinking about it. Okay, so the first one is, again as before, like I'll just come out with my own custom macro just so that I can show you what is happening under the hood whenever you start invoking all these macros over here. Okay, so over here we do the usual defining of a variable attached to the model M, and then we might have an expression like x greater than or equals to 0. Again, you end up with these symbols and expressions over here. If you step through the code for the variable macro, you'll see basically what it is doing is it is making use of the information that's captured here in order to generate the code that's needed to write in order to define the variable over here. And I won't go through how it arrives at all this stuff, but basically at the end of the day, let me see what's the best help. So what it is doing is it is basically generating a symbol corresponding to this variable, and then it's calling this method called construct variable, okay, where the first argument is the model that you're creating this variable for, and then sort of followed by a few other kind of usual attributes of this variable. I guess in this case it's the lower bound and the upper bound. Okay, after that you need to register this variable inside the JuMP model, just so that inside the JuMP model's dictionary it has access to all these variables. And kind of that's basically it. So the learning point from this kind of excursion into the variable macro is basically that you might want to start looking at how you want to work with this method called construct variable with a bang behind, in order to like maybe overload it for your own custom variable types, for instance. Okay, and for more involved example like before, you might have kind of indexing for your variables, so your variables are somewhat more complex, and then you might want it to be symmetric. If you're Benoit, you kind of want to work with polynomials and stuff. Okay, so again, sort of stepping through the code, you kind of see, and I'll leave this as a homework to you, that like basically what it is doing is it is basically generating loops, and then because this is symmetric, so you want to make sure that it is symmetric by construction. And again, it's basically just calling construct variable along with the information that was passed to you inside the invocation of the macro. Okay, so I guess the main story here is you're getting this information and then sort of like you're kind of diving into JuMP's macros just to have a sense on like, if let's say now you want to modify it somewhat to work with your own custom types, here's what you need to look at, for instance, in order to be able to have a discussion around that. Okay, the last one is JuMP.addConstraint. Again, I think in the interest of time, I'll skip through this. I'll upload the notebook later on, so you can sort of have a look through that. But the last one is basically JuMP.solve. Okay, so the code for this is actually quite complex. I think it's like 150 lines or so. But the main idea is, if you want to have your own custom behavior when calling JuMP.solve, there is this thing called solve hook, okay, which is attribute of the JuMP model. So you can always override the solve hook inside JuMP's model, and then when you invoke solve, sort of make sure, I think everything would just work out for you. So usually, most of the time, this solve would be nothing, and so that would be fine. So when you replace it with your own solve function, it would then use that instead of the custom solve, instead of the default JuMP.solve behavior that you otherwise have. Again, you can sort of look through JuMP Chance's solve hook and its model to see how this is done. The basic idea is basically inside Chance's model, you are creating a JuMP model, and then sort of you are setting the solve hook to be some custom function that's defined inside your package. And so later on, when you call solve, it will then call this custom function that you have to write yourself, that you name solve hook or whatever else you want to name it, and then you then write the custom code for how you might want to solve, maybe possibly generating cutting planes and iterating, so on and so forth. Okay. So I think I ran short on time, but I'll be happy to talk to you more about this stuff. So I think just to wrap this up, what I put this, we have a quick sense on why you might want to care about macros, possibly if you're writing your own macros versus if you want to understand what is happening under the hood in JuMP. We step through a few quick examples, and I guess kind of what I hope to get out of this meetup is basically having a more stable or mature way of thinking about extensions and what we can hope to rely on whenever we're writing our next extensions, so on and so forth. Because I don't think JuMP has a particularly good history of thinking about extensions, and most of it is just kind of on a by need basis. So whenever we've tried writing documentations for extensions, and this was 3 years ago, it's just kind of no, you know what, let's put this off for later on. And JuMP is nearing 1.0, so maybe this is something we might want to revisit with much higher priority for now. So, and if we don't do so, sometimes extensions that build using all these internal unexported methods might break, and so it doesn't result in a very good user experience for people over here. And so I'll leave you to follow through all these links on your own, but I'll just end on that note. Yeah.